When a boat is crossing a river with flowing water, two velocities come into play: the velocity of the boat relative to the still water, let's call it v boat, and the velocity of the river flow, let's call it v river. The boat's velocity is its speed and direction relative to the still water. If the boat is moving straight across the river, its velocity is directly across the river. The river's velocity is the speed and direction of the water flow. It's important to note that this velocity acts perpendicular to the direction of the boat's motion. If the river is flowing from left to right, the velocity vector points from left to right. Now, we can determine the resultant velocity, v resultant, which is the net effect of both the boat's motion and the river's flow. This is essentially the vector sum of the boat's velocity and the river's velocity. The magnitude and direction of the resultant velocity can be calculated using vector addition. If the boat is moving straight across the river, that is, perpendicular to the river flow, the magnitude of the resultant velocity can be found using the Pythagorean theorem. V resultant equals square root of v boat square plus v river square. The direction of the resultant velocity, can be found using the inverse tangent. Equals sin inverse of v boat by v river. If the boat is not moving straight across the river but at an angle, you can use vector addition to find the resultant velocity. This involves breaking down the boat's velocity into horizontal and vertical components and adding these components to the river's velocity. Understanding resultant velocity is crucial for predicting where the boat will end up after a certain time, taking into account both its own motion and the motion of the river. It helps in navigation and understanding the overall effect of two simultaneous motions.